Welcome to another video. In this video, we're going to talk about what differential equations are all about. Well, first of all, what is a differential equation? It happens to be any equation that involves a derivative in it. So for example, take this equation. It involves the first derivative, so y prime plus y equals 2. This is an example of a differential equation. Here's another example of a differential equation. Again, it is an equation, and it has multiple derivatives in it, a second order as well as a first order. And we could further push this to partial derivatives. Again, we have an equation with two different types of partial derivatives in it. We have a differential equation. And then this can become even more complicated, where you see here we have a third order derivative, a second order derivative, and a first order derivative. Again, we have an equation, so we have a differential equation. So what does it mean to solve a differential equation? Well, think back to what it means to solve regular equations, like x squared minus 4 equals 0. What we were looking for were numbers where, when substituted into this equation, made both sides true. Well, when solving a differential equation, instead now we look for a function where, when substituted, make both sides true, and it makes both sides true on some open interval. I'll remind you that an open interval happens to be an interval of the form where a and b are the endpoints, and they happen to not be included. So for example, we want to check, is e to the x a solution to this differential equation? Well, we start by finding the derivative of this potential solution. The derivative of e to the x is e to the x. We plug these in to the original differential equation, which gives us e to the x equals e to the x. And we know that this equation is true for every single value of x, hence from negative infinity to infinity, which is an open interval, and therefore, yes, e to the x is a solution. As another example, what happens if we check if y equals 2x is a solution to this differential equation? Well, again, we start by finding the derivative. The derivative of 2x is 2. We plug these into this equation. And when we do so, we get 2 times 2 minus 2x equals x. Or if we simplify this, 4 minus 2x equals x. This can be simplified to the equation 4 equals 3x. And this equation is only true at the value for 4/3, which is not an open interval. And therefore, no, y equals 2x is not a solution. It needs to be a solution where both sides are equal on some range or some interval of values. So y equals 2x is not a solution, but what would be a solution to this differential equation, you might ask? And it turns out that there are not just one set of solutions, but a family of solutions, which is some constant times e to the x over 2 minus x minus 2. And you might be asking yourself, where the heck did this come from? Well, that's what differential equations is all about. Figuring out solutions, namely functions who make differential equations equal on both sides on an open interval. So really quickly, I wanted to show you that in fact, this family is indeed a collection of solutions. So what do? Well, we start off by finding its derivative. And the derivative of c times e to the x over 2 is c over 2 times e to the x over 2 minus 1 minus 0, right? The derivative of x is 1, the derivative of 2 is 0. When we plug these in, then 2y prime minus y becomes 2 times this derivative quantity minus the original function. And if we simplify this right-hand side, we distribute and remove parentheses. Then we end up with this here, which notice that both of these c times e to the x over 2 terms cancel, as well as the constant 2's cancel, and we're just left with just x, which was their original equation, which means that both sides were equal on this full interval of all values of x. So, hopefully you'll stay tuned for even more videos. Thanks for watching. We'll see you in the next one.